Okay guys, so my project today is just to make this aluminum square tube rail, so I can just use the concept to build my next laser engraving machine or next CNC machine just is larger than the 3018 just I'm using right now. So first step, I just want to design a kind of like linear bearing using the ball bearings. Though a skateboard bearing that's very cheap, so you can buy 10 of this for less than $2 on AliExpress or on eBay. And this aluminum square tube is also very cheap. You can buy like 48-inch length of this tube for less than $10, though 3/4 of an inch side, so 18.9 millimeter. Let me just go on the computer and show you what my design looked like. Here's my design for the linear bearing. I have four plates like this just to fix the M8 bolt in place, and have the 16 of the ball bearing will be slide on the M8 bolt with the spacer here in between to keep the bearing from sliding side to side. Those spacer have the dimension of 23 millimeter and 6.9 millimeter. You would need to be exact when you cut those spacer, because it's just enough to prevent them to jump off the tube. As long as they stay on the tube, it will keep the tube like in place and sliding smoothly. Okay, so the next step just I'm going to show you is to test the size of all the holes that I'm going to cut, and the distance between the holes, just to make sure that I don't have much play between the bearings and the tube. Okay, so here's a plate with the row of holes. Just the dimension just vary from 8 to 8.4, as you can see here. Yeah, so the first one will be 8 and the last one will be 8.4. I just going to test to see which hole just can make the M8 bolt slide right through. The reason just I choose the smallest one is 8, because my CNC machine is usually cut a bit, the holes a bit smaller, so usually the M8 bolt not going to go through this 8 millimeter hole, so that's why I just go from 8 to 8.4. Let me just go on Fusion 360 and show you quickly how I cut these holes. You probably know this already, so you can skip it. Okay, here in Fusion 360, I just want to open the file just I already saved in step format, test hole size. Okay, so just go to manufacturer directly and create a setup. So box points, I will choose this one. Stock, well, 0, 0, doesn't matter. Okay, so I just going to do 3D pocket clearing and select the tool, whatever tool you use. I use this one, and bounding box, well, this label bounding box, I choose here selection, and tool is inside the boundary because I'm cutting the hole, and I'm going to choose the bottom here, and here I have to reduce this to 1, and I want to cut through, so I just put like minus 0.04, just a little bit, so it can cut really through the hole. Here don't leave any stock, and here I just going to go shortest path. That's it. Okay, it look correct to me. It go always through, even with some extra. So I just going to go downstairs and cut this out. Okay, so I have here the plate with the hole just cut out. So first step, I'm going to try the smallest one, is like 8 millimeter, which were supposedly designed for this M8 bolt, but it doesn't really go through. It's kind of really tight, you cannot really push it, only the tip of the bolt goes through. So, and 8.1 is actually the right size here, and you can see that it have kind of minimum play, and it just goes right slide through. So that's what I'm going to use for the next step. Okay guys, so here's one of the side plates that I need to cut out, but before doing that, what I need to do is just to test the distance between the holes here to reduce to minimum the play between the bearing and also the rail. The diameter of the hose here will be 8.1 millimeter, just like I tested before, and the distance here from here to here right now is have the side of the tube is 18.9, and also 8 millimeter on each here side here, from the side of the tube to the center of the bearing. If you use different tube and different bearing, just add it on and change the distance here. Right now I just going to use those distance to cut out the hose and see how much play I will get. If it's too much, I just reduce slowly until I get the reasonable level of play. Let me just test it. Okay guys, so I cut here the plate with the 4 holes. So you can see that the screw just like the bolt just slides through very easily, and doesn't have much play. So I just slide all the bolts through. Okay, so I'm just going to slide on the ball bearing here. Okay, so now I'm just going to slide this through in between and see what type of play that I have. Okay guys, so surprisingly I just don't have much play on this because I haven't like really reduced the distance between this bolt, but it's really like tight, and when I roll this strip around like this, all of the 4 bearings were rolling. That means they all touch the tube with some force. So actually I don't have much play. I cannot really move it from side to side. So this will be actually the dimension that I'm going to use for the linear bearing. So next step, just I'm going to cut out all the 4 side plates and show you how I put together this setup of the linear bearing. To cut out the side plate, it will be very easy. I just go directly to manufacturer, to importing the motor and create the setup. Okay, box mount over here. Oopsie, I think I turn it around like this side. Okay, 0, no, I should put some, I want to put 5, put 0 here. Okay, after you create the stock, next step you just go to 3D contour, select the tool, the 4mm flat end mill, disable this, and go here. I'm going to choose selection, and tool is outside of the boundary, and choose this bottom boundary. Okay, that's it. I'm going to go to next step, put 2, 1. This one I'm going to put 0.7 because I don't want to cut it all the way through, so the bottom is higher than the bottom of the motor. So just leave a thin layer so you can to hold this plate like in place, that it doesn't fall off when the tool cut through. And here That's pretty much it. I'm going to reduce this to 0.7, and I'm going to put shortest path for the retraction. Click OK. Oops, it doesn't cut the boundary here, so I had to edit it. I know what's wrong. I had to put 4mm here and click OK. Okay, now it's correct. So next step, well, I just need to check here. Just it leaves like the bottom here a little bit. So next step, I just go to 2D contour. The tool is already selected, so I just going to go here, select contour, this bottom contour, and tap. I'm going to leave 3 and 0.7. Just the thickness of the tab just left from the last operation. Okay, put 2 and 1, 0.5, and this I put minus 0.4, so you can cut all the way down. Yeah, that's it. Okay, I forgot one thing, that I had to cut also all these holes, so I'm going to edit it and contour. Just going to add on the holes. Okay, that's it. So let me just go downstairs and cut this out, and 4 of this, and I will show you how I put together the linear bearing. Okay, so the tab just break off by itself here, but yeah, I have the first plate. I only need another 3, so I just going to show you directly the step where I just put all the setup together. Okay guys, so after cutting and cleaning up, I have here 4 of the side plate. Just I will need to put together the linear bearing. I already prepare all the other stuff like M8 bolt, M8 nuts, ball bearings. You will need like 16 of the ball bearing, or you can just use 8, so you will have 2 on each side of the rail, but that will be less stable, and the duty will be lighter. I prefer to make it kind of heavy duty, so I'm going to use like 4 on each side. You can increase it, you have like heavier stuff. So let's just start to put together the linear bearing. But first, what I need to do is just I have to cut the spacer for the M8 nuts, as I show you on the computer. So I will need to cut like 16 pieces of the 23mm length. These are PVC vinyl tube. It have the 8mm inner diameter, so it fits perfectly for the M8 bolt. I just bought it at Lowe's. So let me just cut the pieces first. And the length of this, you don't need to be exact, but try to be like 23mm or less. Between 22 and 23 will be perfect. Okay, so I have 16 of the long piece, 23mm. I will need another 8 of the 7mm or less of this tube. Okay, so I have 8 of the smaller piece. So now let's just start by doing this. You just slide the bolts through the holes here. Put on the 4 of the long spacer. And then you put on the bearing. And put on the short one. Then another bearing. And another long piece. And now just put this piece on. Just make sure that you have the same side like this. The long distance from the edge to the hole, and flip the groove here. Okay, press it in and put on the nuts. Now you don't need to tighten the nuts yet. Just put them in so it doesn't really move around. So now on the other side plate, just do the same. Okay, so now before you put the last piece on this, you just try to fit this on here first before you actually put this on this side. So, but here it's kind of, I just made a mistake, so I cannot fit this in here because the bolt's supposed to go from this side to this side, not like from this side to this side. Because now I cannot fit them in, so next time when you do this, you probably better just put the side plate on this and slide the bolt in so you are sure that it's going in the right direction. So I'm just going to have to pull this out. It's kind of a pain to pull this out though. Okay, so I just took it out. So here what I'm supposed to do at the first place. So supposed to do this and this, so it fit in here like this, and then I slide the bolts through. So now I'm sure that I have the right direction of the bolts that go in here. Okay, and then I can take it off and put on the pieces. Okay, so now before putting this piece on this, you just have to fit this in here again. This should be the right orientation, so you just slide it in and kind of try to fit it in the puzzle boxes. Okay, like this, and then slide this piece on this side. Okay, so now we have the boxes put together like this. You just need to tighten the nuts here and put on the nuts on this side. I should put some washer here, but now it's just a test, so I'm just not going to do it. And you can see that the bolt here kind of like long, like you have some extra here. I can use this just to put on the bracket later. Okay, I'm just going to go get some wrench and really tighten this a bit more. Okay guys, so now I have the box put together. It's really like sturdy. I cannot really move it in any side. And what I can do to make it better, just I can do like jam lock this bolt here using another nut on top, like this, and kind of like just jam lock it so it never moves. Like this. So I cannot really like take this out, so it will really like will be like stay in place. You can do this for all the bolts, but I'm not going to do it now. I just going to show you the principle. And here I just going to try to slide this rail in here. It just goes through quite smoothly, and well, I cannot really feel any type of play when I try to rotate this, lift it up and down. It's really well fit, and as you can see here, you can slide really smoothly on any side. So this is type of like really heavy duty linear bearing, just you can build yourself. And this setup that I showed you, you can just use the same type of concept, like the way I test it and build it. You can do it to expand to other type of tube, another type of bearing, or different type of bolt. You just need to test it a few times to get the right size of the holes and also the distance between the holes. And next step, what I'm going to do is just to try to use this setup to build my laser engraving machine. So I will show you my build later.